So let's go to the actual configuration of the IPv4 spoofing set of tools. You know, the PACL, IP source guard, and then your RPF. So first, let's do that PACL in here on this diagram. So let's go on router 1. I mean, it's obvious that if I change the IP address of router 1 to .200, I'm going to be able to send traffic back and forth. I'm not going to be able to send that because I have dynamic ARP inspection on switch 1. Let me go ahead and remove that from switch 1 dynamic ARP inspection. Let me go on switch 1 and temporarily remove dynamic ARP inspection from that VLAN. So no IP ARP inspection. VLAN 11. Let's confirm show IP ARP inspection. It is disabled, no active on the switch. Okay. So it's obvious that if I go on router 1 and change the IP, this IP to .200, I'm going to be able to send traffic to PCA without any problems. That's no problem. But of course, to prevent IP spoofing, let's say inbound from router 1, I'm going to go on switch 1 and inbound on this port, apply a PACL, which is going to allow traffic on an interface sourced only with the .1 address of router 1. So let's go on switch 1. And I'm going to say IP access list extended router 1 PACL. And I care about permit IP host, the IP address of router 1, 10.10.11.1 to any. I don't care the destination. I care about making sure that a source is 10.10.11.1. And then I go at the port facing router 1, which is a layer 2 port. And I say IP access group router 1 PACL inbound. So now router 1 should be able to ping PCA clearly. But if you go on router 1 and you change that IP address, we change the IP address of router 1, traffic is not going to work. Let's say .11, because I have that PACL which drops traffic now, because now traffic with that source is going to match on the implicit deny IP any at the end of the ACL. So ARP is going to work because the IP ACL doesn't drop ARP traffic. So I have an ARP entry for PCA, and also PCA should have an ARP entry for the new address of router 1, which is .11. And there we go, it has. So ARP it works, no problem. But IP traffic is not going to work. If we ping now, the switch is going to drop those packets inbound, as expected. So that was the PACL. Let's go back on router 1 and put back the IP address, because that's the default gateway of PCA in that VLAN. Let's make sure I can ping back again. There we go. Let's go on switch 1, remove the PACL now, and move over to IP source guard. Now, with IP source guard, clearly it makes a lot of sense to, in general, apply IP source guard. Of course, as I stated, nowadays it's no longer used. You're going to use other better options for that. But still, I'm going to enable IP source guard on this interface. Traffic is going to be allowed because when I get traffic inbound with a source of .100, switch 1 is going to validate that source against the DHCP snooping binding table. Let's confirm that. Let's go on switch 1 on port FA105 and enable IP source guard. IP verify source. If we say show IP verify source, It says that on interface FA105, the filter is active, and I've configured the filter to do only IP filtering, source IP filtering. Filter is active. It can be also inactive if, for example, DHCP snooping is not configured. And switch 1 knows that it's going to accept inbound traffic on that port of FA105 only if the source is 10.10.11.100. It knows this. It knows this from the DHCP snooping binding table. If you say show IP source binding, there we go. It says that. So this output in here is actually as a result of interpreting the DHCP snooping table from here, which this states that the MAC address of that, which is a PCA, which belongs to that IP address, this is the data read from the DHCP snooping table. There you go, the leads value, and I know that information from the DHCP snooping table, and that's an entry in VLAN 11 on port 105. So based on that information, and based on this information from the snooping database, and based on my configuration, I'm going to end up from this information in here with the output of show IP verify source. So let's confirm that PCA can send traffic in the network now. I can ping 10.10.11.1 the default gateway successfully. Now if I go and also configure source guard on this port, when switch 1 receives an IP traffic with source of .1, which is router's 1 address, is going to drop it because it doesn't find that entry in the DHCP snooping binding table. So let's go on port FA101, enable that feature as well. IP verify source. So now if we say show IP verify source, well, it's inactive is going to work because that's a DHCP snooping trusted port. So it is going to work, and it makes sense because on that port of FA105, because that's a DHCP snooping trusted port, and source guard relies on the DHCP snooping table, it makes sense that IP source guard is disabled because snooping trust is on. So router 1 should be able to ping PCA. But if I put that port to DHCP untrusted state, and I say show IP verify source again, then there we go. The switch says now that if it's going to receive traffic inbound on that port, it's going to do a check on the source IP address. The filter is active this time, and I'm going to deny all traffic because I failed to find an entry in the DHCP snooping binding table for that interface. So router 1 ping should fail now as expected. So if I want to fix this, because this port in here faces a statically assigned address of router 1, I'm gonna go in switch 1's configuration and do a static binding of IP to MAC to be used by. So I'm gonna do a static binding of IP to MAC, which is gonna be used by IP source guard in there. So conft IP source binding. What is the MAC address of router of the device connected on that port? It's AAA. What is the VLAN? 11. What is the IP? And what is the interface? Just like, because this is like an entry from the DHCP snooping binding table. That's what it is. MAC to VLAN to IP to interface binding. So now if we say show IP verify source, it's going to state that now when I get traffic inbound from FA101, I do a check on the IP source filter is active, and I only allow traffic source with 10.10.11.1. If you say show IP verify, show IP source binding, you see the entry which is configured statically. So the switch knows that MAC address with that IP address it never expires because it's a static entry. Those MAC and IPs are actually reachable out on port FA101. And I did a typo in here, which means it's not going to work. I said 3 A's in the end, which means it has auto-completed the MAC entry with 0. So let's fix this up, because now if I'm going to ping, it's not going to work. So let's put in there properly 4 A's in the end as well. Show IP source, show IP source binding. Now the proper MAC address shows up, and show IP verify source. Okay, so now I should be able to ping from router 1. There we go. But likewise, if I change the IP address of router 1, again, it should not work. Show run interface gig00, because the switch allows traffic inbound from router 1 only if it has an IP source address of 10.10.11.1 per my configuration. So likewise, if I change the address, it is not going to work. Again, just to confirm, that's not an ARP issue. CLS ARP worked. The PC has an ARP entry for the router's new address, that 11, and the router has an ARP entry for the PC's address. We should when I'm going to ping, but IP traffic is being dropped by the switch. So ARP worked, but IP didn't work. It was dropped by the switch's IP source guard configuration as expected. So let's put this back to what it was. Okay, before we go to URPF, because we're done with the layer 2 spoofing part, there's a question from Matthew. So Christian, what is newer method that is better than source guard? So nowadays, as I stated, if you ideally nowadays, because it's very important, it's the core of a security architecture, you should always authenticate and authorize all terminals connected to the network. Like all user devices, all laptops or computers, or all desktops, all printers, all IP phones, all video conferences, all mobile phones, everything should be authenticated in the network. So once you perform that authentication via 802.1x, which makes use of IP, that's going to be for corporate devices, via MAB for devices which don't support 802.1x, via HTTP, HTTPS for guests which are connected in your network, or via proxy, cut through proxy, or via proxying features. So once you authenticate everything which is connected in your network via radius in there, once those devices are going to be authenticated, so once this, if you look at our diagram in here, once this PC is going to get somehow authenticated when it connects to this port in here via those methods, then as part of the authorization and authentication process, on this port I'm going to have built-in port security. So port security is built in. You don't need to configure it. Likewise, IP source guard is built in as long as from the radius server, you receive as part of an authorization an access list to apply dynamically inbound on that port. So port security is built in, IP source guard is built in, so you don't need to enable those capabilities statically anymore in there. So this is the recommended way to do it nowadays. So Matthew, I hope I answered the question. Next, let's go to URPF. Looking at our diagram in here, let's say the following. Looking at this main diagram. Now, router 3 has a route for the loopback of router 1 this way. For the loopback 0 of router 1. And has a route for the loopback 0 of router 2 this way. Let's confirm that. Router 3, that is. So router 3 show IP route 5551. 5551 is not in the table. Is router 1's loopback shut it down from yesterday's configuration? No, it's not shut it down. Is router 1's loopback advertised into router edge IP or not? And doesn't look like. Probably I removed it from yesterday topics. Let's advertise the loopback of router 1. Let's go on 3. Let's confirm that it has a route for that loopback. It has a edge IP route with a next hop of router 1. So 3 has a route for the loopback of router 1. Egress on that direction. And it should have a route for the loopback of router 2 with a next hop of router 2, which is going to be 136.138.2. The address of 2 in that VLAN. Let's confirm that. Router 3. The loopback of router 2. Likewise not in there. Show run interface loopback 0. And show run section router edge IP. Let's put it in there. So it should have the route now. And there we go. With the next hop of router 2. Now what I'm going to do is the following. I'm going to go in router 3, enable URPF in strict mode on this interface. Actually, let's do the following before I do that, to see everything, the whole thing back and forward. I'm going to go in router 1, and fire up a loopback on router 1, fire up a loopback 1, with the IP address of the loopback of router 2. I'm going to spoof that address of router 2. I'm going to send a ping packet with a source of that loopback 1 to router 3, which means router 3 is going to accept it because it doesn't have URPF configured. That's going to be the echo request packet, echo request. And then when router 3 is going to reply, is going to send the echo reply to the actual loopback of router 2. It's going to send the echo reply to the loopback of router 2. So through spoofing, this attacker router 1 manages to perform some kind of denial of service attack against maybe router 2, because 2 receives undesired echo replies packets just because router 1 spoofs its loopback. Let's confirm that. Let's go on router 2, say debug IP CCNP. Let's go on router 1, bring in that loopback. IP address 5552. And now let's ping router 3 on directly connected interface 136.1.31.3 with a source of loopback 1. Repeat, 1 is good enough. Show debug. There was nothing happening. Let's make sure that router 1 can ping router 3. Well, who knows what a problem could be. Actually, let's do a debug on 3 as well because it should work. Let's go on 3 and do a debug as well. Let's make sure that logging at the console is a debug level. Show logging at the console is debug and router 2 as well. Maybe I have accidentally disabled logging at the console yesterday. There we go, it's logging information, right? So that's the problem. Conf t logging console debugging. Let's go again on router 1 and ping. So there you go, it worked. So router 1 send a echo request packet, a ping echo request, with a source of the loopback 0 of router 2, it spoofed the source, destination router 3. 3 received the packet, and it has to reply to the source, but of course 3 has a route for that destination for loopback 0 router 2 this way. So 3 is going to send the echo reply packet with a source of router 3 destined to loopback router 2. So it receives an undesired echo reply packet. Let's confirm that. So 3 got the echo request, and it has sent the echo reply from 3 to the loopback of router 2, and has routed that to the actual owner of that loopback to router 2. They got router 2 received the reply for which he never sent a request to begin with. Now, if I'm going to go on this interface now and enable URPF in strict mode, when router 1 sends again that packet with the source of the loopback 0 router 2, router 3 is going to verify it. It's going to fail the URPF check. Because router 3 has a route for the loopback of router 2 in this direction. So 3 now knows that that's a packet with a spoofed source. So let's confirm that. Let's go on 3 and configure URPF in there on that interface of FA0031 in strict mode. IP verify source. It's a couple of commands. IP verify unicast source RX. So reachable via RX is strict mode, reachable via any is loose mode. It makes sense. Reachable via RX, it means I want to make sure that the source of an IP packet received, the unicast source of an IP packet received, is reachable out on the RX interface that packet was received. While any means that, if I say any, means it's loose mode, because this means that I'm going to verify a unicast packet. I'm going to verify the source of the unicast packet, and if it's reachable via any interface, it's good enough. That's loose mode. So again, the command makes sense as well. So now let's ping again from router 1. And as expected, so now the echo request should go to router 1, the echo request to router 3, but 3 is going to drop it because it fails the URPF check, which means 3 should not send, because it drops the echo request, should not send an echo reply to router 2 anymore. And as you can see, there's no debug output on router 3, even though debug was left on. So 3 dropped the ICMP packet, which means he didn't send the ICMP echo reply, and 2 didn't receive the echo reply anymore. That's the first one. If you go on 3 now and you say show IP interface, that interface of FA0031 where URPF is enabled, you're going to see here at the bottom that I have URPF enabled in strict mode, and 1 packet has failed the URPF check as expected. Now on the SA, let's do the same thing. Let's go on this interface. Before we continue, let's see how ASA3 routes for the loopback of router 2 actually. Show route include 5552 It routes via the outside interface. Okay. So it routes via the outside interface, which means let's do the following. Let me go on router 1 and remove that loopback to begin with. At this point on router 1, remove that loopback of 1. And now let's do the following. So ASH3 also has a route for the loopback of router 3 facing in this direction. Let's confirm that. ASH3. It faces the outside interface with a next hop of router 3. So now let's go on router 2. Configure a loopback 1 to match the loopback 0 of router 3. Send an IP packet in this direction to ASH3. With that source of the loopback 0 of router 3, enable your RPF on the ASA interface in here in strict mode, because ASA supports only strict mode, which means ASA should drop that packet, because ASA has a route for the loopback 0 of router 3 this way, which means that this packet is going to fail the RPF check. Let's go on router 2, bring in that loopback temporarily to match the loopback of router 3. IP address 5553 on debug all. Next, let's go on ASH3, enable URPF on this interface facing router 2. And we can do that from SDM, then from the STL is going to be a very simple command. Let's say refresh CISCO. And you go under configuration under firewall, because it's a firewall feature. And it should be under advanced if it doesn't show up specifically. And anti-spoofing. So I want to enable a URPF on this interface of DSA, which is the SRV interface nameif. So SRV and say enable and say apply, which means, as I said, it's gonna pretty much do the same. It's gonna be a very similar command, but it's globally on the SA. It's not per interface. Actually, it is per interface. It is global. Sure run include IP verify. So ASA has URPF enabled on that interface of SRV, and it doesn't state in which way, because ASA supports only strict mode. Show IP verify statistics. Content no packets have been dropped on that SRV interface. But now I'm going to ping, as I stated, from router 2 with that loopback with the spoofed source of the loopback of router 3, and ASH3 should drop the packet. Let's go on router 2. And let's say ping DSA's IP address with a source address of loopback 1, repeat 1. And if you go on ASH3, we should see, there you go, one packet being dropped on SRV interface because it failed the RPF check in there. Now, for the sake of it, before we continue, let's remove this because I may have asymmetric routing further on in the network, and I don't want to troubleshoot. We want to finish the class this week. And let's go on router 3 as well and disable URPF from that interface as well. And on ASH3 and on router 2, we gotta remove that loopback of router 1, loopback 1, the spoofed one. Okay.